Welcome to today's video where we're going to be taking a look at the graphs that the Maths A-level exam expects you to know off by heart. However, it's worth pointing out there are going to be some graphs we're not including in this video, and those are graphs such as the graphs of the trigonometric functions, sine, cos and tan, and that's because although you are expected to know those off by heart too, I feel like those graphs are deserving of their own video by themselves, so we'll look at them in the future. It's also worth pointing out I'm not going to be including any graphs that you're going to have to do any calculations for before you're able to draw them. So that means any graphs where you have to first find out what the x and y intercepts are, or any other calculations that are like that. And also I'm not going to be talking about graphs that involve graph transformations before, again, you're able to draw them. And that's because, again, transformations is its own whole topic by itself, so deserving of a separate video. Overall, therefore, all the graphs in this video are all things that by themselves aren't really worth any marks. These are just going to be things that appear as part of other bigger questions, and therefore that's why it's so important you know them off by heart. You don't want to be lingering on this part of the question. These things are just going to be one step of a multi-step process, so therefore the quicker you can just draw them and then do the things with the graph that you need to do, the better. So with that said, for every one of these graphs, I'm going to be first showing you what they officially look like using graphing software, and then I'm going to have a go at drawing them myself for you so you can see what characteristics you need to be concentrating on replicating when you're drawing them for yourselves, because you're not in reality going to be able to draw a point-for-point perfect replication of the perfect graph most of the time, and so therefore it's just important to concentrate on what's the main characteristics of the graph that give the person who's looking at the graph a general overview of roughly what that graph looks like. So starting off with y equals x squared, that looks like this. So what do you need to do if you're drawing it? Well, you need to make sure when you're drawing it you've got that y and x intercept of the origin basically, and that sort of general U shape and a smooth symmetrical curve. So although I won't have it looking exactly like they've got it there, something that looks generally like this will do absolutely fine. As you can see, it's not perfect, but it's roughly symmetrical. It has the correct intercept roughly, and therefore it gives the person looking at it an idea that, okay, this is probably a quadratic they're talking about. And on to y equals x cubed, which officially looks like this. And then if you're trying to draw it yourself, you're going to want to have something that looks very roughly like this. So the symmetrical shape is there roughly, and basically that sort of almost flat bit in the middle, just trying to get that across to the person who can see your graph. Okay, the next graphs we're going to be looking at, and I do mean graphs there, are all graphs of the form y equals x to the power of something, where that power is a positive even integer. So that means it's got to be an even number, and it's got to be a whole number, as well as I said, positive as well. Interestingly, all those graphs of that format all look like this, which is very similar to a quadratic. The only thing that's changed, and changes even more the bigger you make the power, is the part at the bottom. This part here becomes more and more flat. So reality, you can do very similar idea to what we did before when we draw a quadratic, but just have it flattening off quicker in the middle. There you go. Again, you're looking for that symmetrical shape. And then on to y equals x to the power of n, where now n is a positive odd integer. And if the even integers look like y equals x squared, well, the odd integers look like y equals x cubed. But again, with that more flat bit around where x equals 0. So when you're drawing it, just make sure your drawing, your sketch, if you will, reflects that characteristic of them. So I'm making it a bit more flat in the middle. There you go. Not the best drawing in the world, but it'll do for the marks. Okay, y equals square root of x. This is a very easy one to remember because it just looks literally like a quadratic turned on its side, and only half of it. And funny enough, that isn't a coincidence, but you'll discover why that is later in the course when you get to the functions chapter. So therefore, when you're trying to draw it, well, similar idea as I said to a quadratic, but trying to make sure you're drawing it on its side like that. Be careful not to make it look like your graph ever becomes fully flat, because the real graph doesn't either. So it's just flattening off a bit, but never becomes fully horizontal. And on to y equals 1 over x, or x to the power of minus 1. Of course, those two things mean the same thing, and these graphs are interesting because they mean we need to introduce the idea of an asymptote. Now, an asymptote, well, first of all, it's spelt as you can see on the screen, but what is it? Well, it's something that isn't part of the actual graph itself and instead is just a characteristic we can see. An asymptote is a part of the graph where it looks like the graph is leveling off into a straight line. The straight line is itself not part of the graph and is invisible, but it looks like the graph is heading towards becoming a straight line in those moments without ever actually quite making it. So for instance, you can see it's happening in two places on the graph of y equals 1 over x. Where the y-axis is, the graph looks like it's heading towards it. It's getting closer and closer and closer and starting to become a bit more straight as it approaches the y-axis, both at the top and the bottom. And it also has an asymptote of the x-axis. And again, it's because you can see the graph is heading towards the x-axis and leveling off, becoming more straight as it does that. So when we're drawing a graph with an asymptote, we have to make sure we're accurately portraying what an asymptote is doing. Therefore, it's very important you make sure your graph doesn't look like it's actually intersecting with the asymptote, because that's a key characteristic of an asymptote. The fact the graph never actually reaches the part where the asymptote looks like it is. So therefore, with my graph, I need to make sure I'm making it look like it's heading towards the y-axis and the x-axis without ever actually intersecting them. So there you go, something like that. Okay, my line is more curved, I should say, is a bit wiggly in the middle, which it shouldn't be. It should be more smooth than this. That's just because I'm drawing it on a less than optimal tablet. It's worth pointing out I've had to take great effort to make sure my line isn't actually intersecting with the asymptote, but also making sure it doesn't look like my graph is accidentally curving away from the asymptote again at the end. It does have to look like it's heading towards it without ever actually quite making it. Cool. Something worth pointing out though is you are actually meant to indicate asymptotes on the graph that you're drawing. The way you do this is by drawing a dotted line or a dashed line. However, that was difficult to do on the previous graph we had because the asymptotes were on the x-axis and the y-axis, and the problem is because we've drawn the axes, there's already a line there, so if you draw a dotted line there you can't see it because of the axis line. But therefore, if a graph has an asymptote that's not at the x-axis or the y-axis, you're going to have to draw that dotted line in. So although I said I wouldn't do graphs that involve transformations, just as a quick example, y equals 1 over x plus 2 gives us the opportunity to show what a asymptote that's not at the x-axis or y-axis looks like. So y equals 1 over x plus 2 is the graph of y equals 1 over x with 2 added onto every y coordinate. And if y coordinates are bigger by 2, that means they're higher up by 2, and therefore this is officially, posh words, a translation of 0, 2. So therefore that graph will look like the graph of y equals 1 over x, but up higher by 2. So therefore I'm drawing the same shape that I drew before, but with the horizontal asymptote being a bit higher than it was on my previous graph. And then because it's higher than the previous graph was, I then have to indicate it by doing a dotted line. Okay, and then it's a good idea, just like with x-intercepts and y-intercepts on graphs where you have to normally calculate those values for, that you indicate the value at which an asymptote occurs as well. Cool. Next graph we're going to look at is y equals 1 over x squared. That officially looks a bit similar to y equals 1 over x, except instead of one bit being above the x-axis and one bit being below, Because x squared is a symmetrical function by itself, 1 over x squared is also a symmetrical function. So therefore, we're going to end up looking like we're drawing something that looks like this, very vaguely. There you go. Again, it's got two asymptotes, the y-axis and the x-axis. Y equals 0 is the x-axis as an equation, and x equals 0 is the official equation for the y-axis. Right, one final graph to draw, and that is the graph of y equals a to the power of x, where a is a constant that can be any constant you like, and it'll have this same rough shape as long as that constant is a value bigger than 1. If that's the case, the graph looks something like this. Just so you're aware of, the graph I chose to draw was specifically the graph y equals 2 to the power of x, but as I said, all the graphs of this format, as long as it's a number bigger than 1, will all have a similar shape. Something worth pointing out that's quite important about these graphs is they have a horizontal asymptote, an asymptote of the x-axis. So again, you've got to make it look clear on your graph that it's not actually quite making it to that asymptote. Even though it looked like that's what's happening on the official graph, that's just because I zoomed out too far, and therefore if you zoom in you will see there's still technically a gap between the graph and this asymptote. And also, there's something else that's very interesting about these graphs, and that is that they always have a y-intercept of 1. And so knowing that and indicating it on the graph is important. Interesting to point out that y-intercept of 1 is also, again, always true no matter the value of a, as long as it is a value of a bigger than 1. So y equals 3 to the power of x would also have a y-intercept of 1, and y equals e to the power of x also has a y-intercept of 1 if you know what e is yet. If not, don't worry, we'll cover that in a future video as well. And lastly, just to satisfy the curiosity of some people, you now know what y equals a to the power of x looks like if a is a value bigger than 1, but what happens if it's other values that are not bigger than 1? Well, first of all, if a is less than 0, it's worth pointing out you can't even draw the graph, and that's because if you've got a negative number to a power, first of all, it's constantly fluctuating between being a positive number and a negative number, depending on if you've taken the power as an even number or negative number. But then also, you can't take negative numbers to fractional or decimal powers if you want to get a real number as an output, which is therefore something you're able to draw. So that's why you can't even draw the graph if a is less than 0. If a is a value between 0 and 1, you can draw it, and actually it just has the same sort of shape as if a was bigger than 1, but that shape reflected in the y-axis. So every single graph where a is a value between 0 and 1, same shape, but just reflected in the y-axis. If a equals 0, then it just becomes the line y equals 0, or at least pretty much, and that's just because technically 0 to the power of 0 is undefined, so there's one point where the graph is not defined for. And lastly, what if a is equal to 1? Well, that's also just going to become a straight line of just y equals 1, and that's because 1 to the power of anything is 1. Nice! Okay, hopefully you found this video useful as a good summary of all the graphs you're just instantly meant to know off by heart, and therefore, hopefully, I'll see you in a future video. We still do have more graphs to look at, but as I said, we will cover them in the future. Goodbye!